Okay, so I start here. For how long do I continue to go up? Until I get at what value? That's right. So I increase from negative infinity to negative 3. Okay? And then Seamus, as I'm looking at this, because now your name's on there, I'm going to be going down. Okay? And then I'm going to decrease from where to where? Where am I decreasing from on the graph? From what x values to what x values? I'm going to go down from negative 3 to negative 1. And then I'm going to, what happens right here at negative 1? I'm going to start increasing again. So over here, I've got to put this union in there again and say that from 1 to infinity, I am continuing to increase.
Why negative 1?
Oh, sorry. Thank you. Yep, that's a 1. Thank you. Just to 1 there. Okay? Any questions on that? Okay? Okay, Kyle.
Can you write down the definition for union?
Yep. The union just means and.
Yeah, we got that.
Stop. Okay? To connect or include? Both. That is why we put the union symbol in there. To connect both of those intervals and to include them both within it. All right? Okay. The next thing is called, I'll put these out here again. The next thing is called boundness. Boundness, this has to do with y values. Okay? It is how high or low a function is. Example, y equals x squared minus 1. That's a parabola, and what is that parabola doing? What's this parabola doing? How's it moving?
It starts down 1.
Okay, here at negative 1. Now, because this function continues on into infinity for y values, we say that this particular function is bounded below. That's all you need to say, is that it is bounded below.
Bounded below the x-axis?
No, it's just, that means that it stops and it does not go to negative infinity. Okay? It's just bounded below. It reaches a bottom point. Okay? What if I had this? Y equals negative x squared plus 3. What does the negative x squared mean? It flips how? Upside down. And it goes what? Up 3? So it looks like this. Now, because this continues on into negative infinity, how do you think this one's bounded?
Bounded above.
It is bounded above. Okay? Now, if I had y equals x cubed for some reason, okay? Let's say it goes like this. That's not exactly x cubed, but it's a cubic. Okay? In this case, do you see how there's a top right here and a bottom? Overall, because this function continues up here into infinity, and this one goes to negative infinity, we say that this is unbounded.
It's not connected.
It doesn't, it's not, it continues on, yes. The y values don't stop. The range is basically negative infinity to infinity.
Okay, what if it it's just an upside down parabola?
Like this,
Oh.
it'd be bounded above. Okay? Now, some of the other functions that we're going to learn are, let's say we have y equals, let's say, sine of x. That's a trig function that you may have encountered last year. Okay, what about this one? This one, okay, it stops up here, and it's supposed to be even, stops down there. So this particular one, because it can't ever go up to infinity or negative infinity, this is called bounded.
Then it has a range.
That's correct. It has a very distinct range. Yes. And in this case, for sine, it's from -1 to 1.
So it has a range of 2.
Yes, that's how high and how low it goes. That is correct. And you'll find that if there is a range other than negative infinity to infinity, it is somehow bounded. All right? Okay. Are we good? Can I go on to the next one? Not yet? Okay.